Regents Review number 20. Question 1 shows a function graphed on the set of axes. You're asked to identify the domain of this function, how far left and how far right the graph reaches. You'll notice the left side has an arrow and the right side has an open circle. So we're looking for a greater than or less than sign without any equal to signs, which none of the options have. This notation is pronounced the set of x such that x is either greater than or less than one of these values. So we know we're talking about the set of x, and we know that the graph extends infinitely to the left. But it cannot be greater than the value of 2. So that means that it has to be less than 2. Question 2 asks you which ordered pair is not a solution to this equation. Well, there are two ways you could solve this. One is you could erase and replace the letters x and y with any of these optional ordered pairs. Or we could rewrite this sentence so that it is in y equals form. Even without distributing, I can just modify this statement and type it into my calculator. So in my y equals button here, I'm going to type 4 parentheses x plus 1/8 close the parentheses, and then put my plus 2 on the side. Now when I look at the table of ordered pairs, you'll notice it's all in decimal values. I can change this by, instead of typing the fraction 1/8, actually typing the decimal of 1/8. So I'm going to delete this fraction here, and I'm going to press this insert key so I don't type over everything. If you don't know what 1/8 is, you can simply divide 1 by 8 on your calculator and change it into decimal form. So here, again, I'm going to arrow over, press second delete to insert my 0.125. Now, when I look at my table of points, I have decimal values. Now you notice all of my x values are integers, but in my options here, my x values are often decimals, like 0.75s. So I think what I'm going to do is I'm going to change the table settings here in the second window. Instead of my table changing by ones, I'm going to make my table change by 0.25s. Now when I go back to my table, I can see lots of different options. So let's start with option number 1, negative 2.75. So I'm going to arrow up until I get to negative 2.75. It looks like that is a solution. Option number 2, negative 2, negative 5.5. That is also a solution. How about positive 0.75? So I'm going to go down the chart now. Positive 0.75. That is not a solution. Let's just double check the 2. That is. So that means that option 3 is not a solution. Something else that you could do besides changing the table settings to go by 0.25s is simply type the x value you want here. Let's just start at 0.75. Even if you kept this as going by ones, you could still double check to see if 0.75 is the right answer. Right? Instead of changing the delta table, you could change the start of the table. Maybe make it negative 2.75, like we were checking before. That's a quick way to get exactly what you're looking for. Question 3 asks you which expression allows this student to change her rate to minutes per mile. When converting, remember that units only convert if they cancel in the numerator and denominator. So this one has minutes and miles left. That looks correct. This one has miles over minutes, which is incorrect. This one doesn't have enough cancellations. And this one doesn't have enough cancellations. Question number 4 asks you which statement can be modeled by a linear function. Linear function has no percentage changes, no doubling, tripling, or timesing. Therefore, we could say that it has a $30 per month, right, constant rate of change. This one asks you to name an appropriate value for W so that this remains a function. A function means that every input has exactly one output. So you can't repeat any x values with different y values. So this number can be any number but not a 7, not a -2, not a 3, or not a 6. I can pick any number that I like. So I'm going to pick 13. Explain my reasoning, and this is where I'm going to state every input can only have one output. That's the answer for no matter what number you pick. Number 6 asks you to write a linear regression. We'll need our TI-84 calculator for this, and we will enter our information into the Stat Edit button. So I've entered the age in list 1 and the target heart rate in list 2. Once I've done that, I can click Stat, arrow over to Calc, and choose number 4, Lin Reg. Press Enter 5 times, and here I will see 2 values. This will give me the equation that I need to answer the first part of this question. We are asked to round the values to the nearest thousandths. Therefore, my A value will be -0.664, and my B value will be plus 148.536. The next question asks me to state the correlation coefficient, which is not currently shown because I don't have my diagnostics turned on. The fastest way to get there is in the mode, arrow down to Stat Diagnostics, turn it on. Once I go back to Stat and I calc Lin Reg again, after I press Enter 5 times, I'll see the R value at the very bottom. Not R squared, but the R value. Again, rounded to the nearest thousands would be 0.999. The last question asks you to state what the correlation coefficient suggests about the linear fit of these data. There is a strong, because the number is very close to -1, and it is negative. There's a strong negative correlation between, and here's where we write the X and Y labels, between age and target heart rate. You can also state, as age increases, that's how it always starts, X increases, heart rate decreases. Question number 7. For this question, you're asked to choose between a linear or exponential model. So by a quick look here, we can see that the X's are increasing by 1 each time. And it looks like this Y value, or the number of bacteria, increases about 60, then by about 70, and 90, 110, 140, and so on. You can see that it does not have a constant rate of change, right? This pattern is increasing a little bit more each time. So therefore, this would be an exponential model. So we're going to write exponential. And there are a few reasons that you can state, but what I see here with my own patterning is that it does not have a constant rate of change. Another answer you could give is why it's exponential. You could just state exponential. It has a constant ratio. Another response that is often given is when students type the information into their TI-84 stat edit button and then calculate both the linear regression, number 4, and then write on their paper what they see. Lin reg, you can write the A value, you can write the B value, you can write the R value. And then you do the same for exponential regression. Again, you write the A value, you write the B value, and you write the R value. In this case, you could say that an exponential fit would be better because it has a stronger, right, correlation coefficient. And there's the proof. Question number 8 asks you to solve algebraically. You're going to distribute here. Then I'm going to combine like terms on the left side. Then I'm going to, I think I'm going to add 3x to both sides. I'm going to subtract 24 from both sides. And I'm going to divide by -2, which is going to leave me with a reversed order inequality, and states that x can be any value greater than or equal to 6. And now for the follow-up question. If x is a number between 4 and 8, state all integers that satisfy the given inequality. Well, it says I can be equal to 6, so 6 would work, 7 would work, and because this is a bracket, 8 is included, so 8 would work. These 3 solutions would work. Number 9 asks you to graph these 2 equations on the set of axes below. So in your graphing calculator, in the y equals menu, you're going to type the first function f and the second function g. From there, you can look at your table of points and determine what scale would be appropriate for this first quadrant axis. So I know I'm going to start at 0 here, and it looks like maybe I can go up. Goes up to 1,000, 2,000. This second function gets real fast, real quick, because it's exponential. So let's see. Maybe we can go by tens. Let's see. 10, 20, 30, 40, 50, 60, 70, 80, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. My first function starts at 0, 0, and then I'm going to estimate these points here. So my first function I'll graph in blue, 0, 0, 1, 1, and so remember these go by tens, so it's going to be very low here. And then 2, 4, also very low. 3, 9, that'd be very close to 10. 4, 16. 5, 25. Halfway to 30, right? This is 30. And then 36. Then 49, 30, 40, 50. So it'll be right before 50. And then 64. And 81. And then, oops, that's not right. 81, and then 10 is about Whoa, 10 is about 100. Okay, here we go. And now the second one, y2, that looks like, I'll graph that, oh, let me graph this one here and label it f of x. And now my second one, let's see if I can just graph a couple here. 0, 1, 1, 2, 4, again, very similar. 3 is 8, just below here. And then they're the same at 16. And then all of a sudden this jumps up 32, 64, 128, 256, all the way off the grid. So this one will be g of x. All right. Now the question says, state which function has a greater value when x is 20. Justify your reason. So you can either write the table from your TI-84 here. You can go all the way up to 20. Or you can show 20 being substituted into each of the equations. So f of x equals x squared. So if I put a 20 here, I got to put a 20 there. And then for g of x, same would be true. 20 here and a 20 there. So I can compute. Or I can set my table to start at 20. Table set, start at 20. And now I can take a look. 400, and look at that other one, is so long it's using scientific notation to write the answer. So I'm going to compute that just on my main calculation screen here. 104,8576. Oops. 104,8576. 1,048,576. So state which function. I have to state. So g of x has a greater value. You actually have to say it. And there's my justification. And that concludes Regents Review number 20.